Let's look at the next example, problem 3. How can I tell if something is a function? Well, in order to be a function, each domain, I know my left hand's in the way there, can have only one range. All right, so let's look at A. A is a mapping diagram, so these are your domains. Can you see how -3 only has one range? It only points to one thing. 0 only points to one thing, and 4 only points to one thing. So yes, this is a function. Each domain only has one y. Now this one's written a little differently, so we just have to be careful with our domains. So I have a 4 and it's paired with -1. But do you see how there's another 4 and it's paired with +1? That's not allowed. Okay, so this is not a function. The domain of 4 has two different ranges. That's not allowed. Let's look at this last mapping diagram. 8 is good. I like 8. It only has one arrow coming from it. -1 is okay. 0 is okay. But do you see how this 15 has two ranges that it's going to? That's not allowed. The domain of 15 screws it up. So this one is not a function. Just as an FYI, these can have, see how 9 has like 3 arrows pointing to it? That's fine. That doesn't matter. But the fact that the domain has more than one arrow, that's what's not allowed. Problem 4. We're going to test this vertical line. So it's like the same thing we were doing in problem 3, except in problem 4, we're just going to pass a vertical line through. So I'm actually going to get, well, I have a ruler. I guess that would be okay. I'm going to pass a vertical line. Now, for the domains to have more than one range means it can't touch twice. So I'm going to write can't touch, that was my email, twice. Okay, so let's look at A. So right here, if I put a vertical line right where I have this ruler, do you see how it would touch 2 times? It would touch here and here. Remember how I drew a vertical line right here? That's not allowed. This one is not a function. It can't touch twice anywhere. Now let's look at B. This vertical line only touches once. So if I like draw a vertical line here, see how it only touches once? Or vertical line here, it only touches once, or vertical line here, or vertical line here. As long as they only touch once, that's fine. So this one is a function. Each domain has only one range. Now we'll be real careful on C to line it up right. A vertical line here only touches once. Vertical line here only touches once. A vertical line here, see how it touches twice? This is no good. This is not a function. It can't touch more than once because then the domain has 2 ranges. Problem 5, using function notation. What is the output for the given input? So they give us this function rule. I'll zoom in a little closer because it's kind of hard to see. We have -2x plus 5, and we need to figure out what the output is. Well, in Algebra 1, function notation is just f of x, and all they want us to do is take this x value on this column, plug it in, and see what we get. So we're going to write it the right way so you know how to. This one says, what is my function of -3? So that's how you identify it. This is not f times -3. This is what is my function if I plug in -3. So I do -2 times -3 plus 5. -2 times -3 is 6, plus 5 is 11. Okay, let's plug in 0. So what is my function if I plug in 0? So I do -2 times 0 plus 5. Well, -2 times 0 is 0, plus 5 is 5. The last one, let's plug in 1/4. Nobody ever really likes to plug in fractions, but if you have a calculator, that's fine. You can use your calculator. So I'm going to do -2 times 1/4 plus 5. This is in function notation showing what I'm plugging in. So it's going to be -1/2 when you multiply here. -1/2 plus 5 is positive 4.5, or we really like to use in proper fractions, 9/2. Or if you really want, you can put 4.5. That would be okay too. Okay? If I ever asked you to write these as ordered pairs, I think your homework does, so I want to make sure you understand how to. The first point would be -311. The second point would be 0.5. Write these down because I want to make sure you can do this on your homework. I know the homework problem asks for it. And then we would do 1/4 and 9/2. Or if you really need to, 1/4 and 4.5. Problem 6 asks you to make an equation based on some information. So like in problem 5, I gave you the equation. So let's see if we can make typically a y equals mx plus b from this. So we have a ticket price. Tickets to a concert are available online, $35 each, plus a handling fee of $2.50. The total cost is a function of the tickets bought. What function rule? I want to make sure we talk about that. What function rule models the cost of the concert tickets? Well, let's go ahead and try to make our function model. So the first thing we're going to say is that they have the cost as a function of the number of tickets. So if we wanted to do C for cost, that would be fine. And it's based on the number of tickets. So I'm going to use C of n. What is my cost based on how many tickets I buy? Well, can you see how 35 is by this word each? That is usually the number that goes by x. In this case, we're not using x, though. We're using n. You can use x if you're more comfortable with it, by the way. And this handling fee is just a one-time charge. I'm going to write one-time charge, which means for us, like y equals mx plus b, it's just the value in the back. It just happens once. It's like the beginning value. So it's $35 for every n, for every ticket, and just the quick little charge of $2.50 that they'll tack on to your final order. So it's really just y equals mx plus b. Here, we could even write it, just like to simplify it for you, it's really y equals 35x plus $2.50. It's the same thing, just in a different notation. It's y equals mx plus b. So now what they want us to do is plug in 4 tickets. Well, does that go in for C of n or just n? It's how many tickets you bought, so it goes in for n. So I'll write my cost based on 4 tickets is 35 times 4 tickets plus $2.50, and then 35 times 4 is 140, and 140 plus $2.50 is $142.50. So that's your answer. Getting my calculator up now. How many tickets were sold at the total cost was $667.50. So this time, this is the cost. This is not how many tickets. So you're going to replace C of n, like all of C of n. It's not C times n, it's C of n. It's like the y value. So we do 667.50 equals 35n plus 250, and solve it using your basic Algebra 1 skills. Minus 250 so that would be 665.00 equals 35n, and divide each side by 35. So 665 divided by 35 is 19. N equals 19. Let's put a label on that. Remember, N was how many tickets. So you really have to figure out when you do these problems, do I plug in for, essentially, do I plug in for X or do I plug in for Y? And then plug in for the right thing and solve for the other one. Okay, these got it. It kind of takes all the past examples we were doing and it says, do you know what to do now? We're putting it all together. So we have f of x equals negative 4x plus 1. What is the output for an input of negative 2? Well, the output is f of x. The input is x. So we are putting negative 2 in for x. So we'll do f of negative 2 equals, so what is my function if I plug in negative 2? Negative 4 times negative 2 plus 1. Negative 4 times negative 2 is 8. 8 plus 1 is 9. Now, this time it says, okay, well, what about an output of negative 10? Well, output is f of x, so I'm going to replace f of x. So I'm going to do negative 10 equals negative 4x plus 1, minus 1, minus 1. Negative 11 equals negative 4x. Divide by negative 4. Divide by negative 4. Reduce. Positive 11, positive 4 equals x. A negative over a negative always equals a positive. Okay, so this would be the input. If the output is negative 10, then the input, or the x value, would have had to have been 11/4. We're going to do a vertical line test again. So in other words, which ones are good? Which ones only touch once? Which ones touch more than once? If they touch more than once, they're no good. So I'm looking at A. Draw a vertical line. Does it touch twice? Yes, it does. This one is not a function. In part B, draw vertical lines. Once, once. That one looks good. Yes, this one is a function. Part C, one vertical line. Every vertical line I'm drawing only touches in one spot. And if you need to, like, you can draw the spots in. But see how they only touch once? That's good. A visual learner likes the vertical line test a lot. I like the vertical line test a lot. Okay, let's see if we can find the domain of that relation. Remember, a relation just means a set of points. It doesn't mean it's a function. It means it's a set of points. So the domain are the x values. So find the lowest x value. Negative 3. Next lowest, x, is 0. Oh, look, they're even in order for us. How kind. 2, 9, 23. You always want to make sure they're in order before you assume they're in order, because they might not be. The range are the y's. Put them in order, lowest to highest. So lowest to me, negative 99. Oh, look, these ones are in backwards order. Then negative 18, then 0, 7, and 14. That was pretty nice. They put things in order for us, kind of. Is this one a function? Let's check out all our x's. Negative 3 only has one y. 0 only has one y. Yeah. So we can say, yes, all x's, or domains, have one y value, or range. So we're good. Last thing, let's see if we can make an equation again. You are buying bottles of sports drinks for a softball game. Each bottle is $1.19. I want you to circle this word each and the number associated with it, because that one typically gets the x value. What function rule? Oh, function rule. That's really just math language for make an equation. Okay? What function rule models the total cost of the purchase? Evaluate the function for 15 bottles. All right, maybe it would be easier for you guys if we did like a y equals mx plus b. Because that's how we, now maybe you know how to do this without doing it, but that's how we did this problem over here, this 35 and 250 problem. Let's see if you guys can find the word each. I see each bottle is $1.19. That's really just your slope. So it's $1.19 for each bottle. If you don't want to use x, you can use b for bottle. Now, there is no base price. So there is no b. There is no y-intercept, because in this problem, unlike the last problem, there is no y-intercept. There's no like it costs $2 to get into the store. Or there's no base price. So in this problem, we don't even have a b. So to put this in function notation, how about we just do f of x? This is really what they're looking for. That's function notation. So instead of writing y, I wrote f of x equals 119 times x. Let's make sure you understand, though, x is the number of bottles that we're purchasing. A lot of kids can do this problem, but they can't make the equation for the problem. So that it's kind of a catch-22 there. Like, you might be really good at just like doing the math, but writing the math is a hard thing for you. So if that we can definitely do more practice with that if you need. Okay? So it says evaluate this function for 15 bottles. Well, bottles was x for us. So we'll do my function based on 15 is 119 times 15. And I have my calculator. 119 times 15 is 1785. So f of x is going to be $17.85. And that's all there is to the lesson. I will see you tomorrow. We'll practice some of this on your own.